So in this video we are going to see about half wave rectifier. What this circuit is all about, we will see in this video. We are also going to do the simulation of half wave rectifier in the Proteus software. So first of all, why we use half wave rectifier? Half wave rectifier is used to convert any AC signal into DC one. So suppose we have one AC signal like this. This is the reference voltage, which is the ground voltage, say 0 volt, and then we have AC signal like this. Okay, by seeing at this signal we can say that this is the positive since it is above the 0 volt, and this is the negative since it is below the 0 volt. So if we want to convert in DC, DC means direct current or direct we can say direct signal which has only one polarity. So getting one polarity means we have to get only upside, okay, or we can say also we have to get only downside, means since we want only one polarity, that is known as DC, but AC has dual polarity. So as much as there that is above, in the same way there is also down. So total area in above cycle and down cycle both are same. So average value of AC will always going to be 0, but average value of DC will not be equal to 0 because it is only unidirectional, but this is bidirectional. So average value will be always 0 in one time period. This is the case for half wave rectifier. And in half wave rectifier, what we will do, we will convert this AC signal to the DC one, okay, this AC signal into DC one. So now we will see what will be the circuit to convert this AC into this DC. So the requirement for the half wave rectifier is not very much. It is only we need two things. One is, the first one is diode, which is the main component of half wave rectifier, and second one is resistor. This is the only two requirement to make any half wave rectifier circuit. Now we will see some working of diode, that what this diode is all about, because since the working of circuit depends on the diode, so we must understand about the diode. So for understanding the diode, we will draw the VI characteristics of diode. So let's draw the VI characteristics. Here is the VI plane. This is the current and this is the voltage applied. Now we can see this is the negative portion, so we can say here is voltage is negative, and this is the positive portion, so we can say here voltage is positive. Now if we want to draw the its graph, so it will look like this. So now we will find the resistance in these two regions. Here is one region, this is the one region in which the graph is parallel to here, parallel to V axis. Now here we can see that for any voltage, current is 0. We can see here that we are applying any amount of voltage, but current is always 0. That's why we can say here the resistance is infinite ohm. So in case of diode, this is the graph of ideal diode, not the practical one. This is the graph of ideal diode. So in case of ideal diode, if we apply reverse voltage, that is negative voltage, then what we are going to get? We are going to get infinite resistance. But if we want or we tend to apply any positive voltage, just tend to apply, then what will happen? The graph will be like this. We are getting any current without voltage, means we don't need any voltage, but we are getting infinite current. This is the situation for R equal to 0 ohm. So we have to understand the diode in two parts. In first part we have the resistance of infinite ohm, and in the second part, that is forward bias, we have the resistance of 0 ohm. So this is the forward bias where the resistance is 0 ohm, and this is the reverse bias where the resistance is infinite ohm. So let's make the diagram of diode also so that it will be more clear. This is the diode in reverse bias. For reverse bias, here we will get negative and here we will get positive. So it can be replaced by any open circuit. Open circuit means resistance is infinite ohm. And for the case of forward bias, that is here, we have the situation like this. Here it will be positive, here it will be negative. So it is the case for forward bias. And in case of forward bias, what we are getting? We will get 0 ohm. So it will be short circuit. It will be short circuit because resistance is 0 ohm and this is the open circuit because resistance is infinite ohm. Here the current is always going to be 0 ampere and here the voltage drop, that is VD, voltage drop across diode is always going to be 0 volt. So this is the two case or the two end characteristics of the diode. Now with these things in mind, we can draw the circuit for the diode. So let's draw the circuit of diode. Now for drawing the circuit, we have remembered that we need just two things, one diode and one resistor. So first let's clear it and then we will draw the circuit. So now we will draw the circuit of the half wave rectifier. So let's draw the circuit. In the circuit we have remembered that we just need two things, one is diode. So let's first of all draw the diode here. Let's draw the circuit here. Let's decrease the size. So this is our diode, and in the diode we have to use one resistance also. In this way our circuit is ready. Okay. So this is the input side where we are going to apply our input signal, and this is the output where we are getting our output, and this is our diode and this is the resistor. Now if we analyze this situation in two parts. First case, forward bias. In case of forward bias, what we are getting, we will be getting the diode will be like this. In case of forward bias, diode will be like this. Here we will be positive and here we will get negative. That is, here will be positive and here will be negative. So what will happen? In case of forward bias, we know that the resistance of diode is 0 ohm, that is short circuit. So we can replace this by short circuit. So draw the next figure. Here we have short circuited the diode. So we have to draw the resistance here, and this is the end part. Now we can see that if we apply any voltage here, we can apply any voltage, let's V volt, then that all V volt will appear also here. Okay, because since there is no resistance in between, so no drop here and there, all the voltage will appear at the output side. So here we can say that this V output is equal to V in. So V output is equal to V in. For which situation? For the situation when there is forward bias, that is this side is positive with respect to this side. Now let's see the situation of reverse bias. In case of reverse bias, the polarity will be just opposite, nothing else. So here we are going to get negative and here will be positive. So the diode is getting negative at this side, so it will be infinite ohm, resistance infinite ohm, and infinite ohm means open circuit. So what will happen? There will be like this. So now what will happen? If we apply any voltage here, any input voltage, all this voltage is going to drop here and there will be no current, I equal to 0 ampere. So the voltage output will be this resistance R into I, and I is since 0, so we are going to get 0 voltage. So V output will be 0 volt, V output will be 0 volt, and here V output will be equivalent to V input. So we can see this situation once by analyzing one graph. Suppose here is the graph. Now here we can see that this side is positive, this side is positive above 0 volt. So we will get this in output, that is V output will be equivalent to V input. So we will get the output like this. We can match this like this, okay. So we are getting the output here, but this side is negative. So what we will get here? Here we will getting 0 voltage. So here it will be like this, because no voltage will appear at the output side. So this will be 0. Again we will get here output in the same manner, since it is the case for forward bias. So it will be like this, and again we are getting the 0 voltage in case of reverse bias. So this is the reverse bias, this is the forward bias, this is the reverse bias, and this is the forward bias. In this way we can understand the working of half wave rectifier. Now what we will do? We will draw this same circuit. We will draw this same circuit in the Proteus software, and we will simulate, and we will see the result like this. We will apply various waves like sine, cosine, or triangular wave, square wave, and we will see that in case of forward bias we are getting the result like this. Here in case of forward bias we are getting the result like this, and in case of reverse bias we will get the result like this. And after that we will also analyze one important condition. So let us go to the Proteus software. Now we can see this is the Proteus software. Here now what we have to do? We have to join the connections. But before joining the connection, let us see all these components. Now we have seen these two components. This one is our diode, okay, and this is our resistor. This is the oscilloscope, and this is our signal generator. So from here we will generate our signals. We can generate various signals like sine, cosine, or ramp, or we can generate the triangular wave, a square wave. So we will generate all these signals one by one, and we will see the output in this oscilloscope. So let's first of all join all the connections. To join the connection, first of all we will connect this diode with diode output with this resistor, and this resistor will be connected to the signal generator, and we will connect this both to the common ground. Means here we have the ground, this all will be at 0 voltage. Now what we have to do? We have to apply the signal at this input. So this is the signal, here is our input, and here we are getting the output. Now we will see this output at channel B. In the similar way we have to see also the input, so this will be given to the channel A. Now our circuit is ready. So what we have to do? We have to simulate it. So let's click on this button to simulate the circuit. Now we can see here this yellow is our input because it is at channel A, this wire, and this is our output which is on channel B. So this blue is our output and this yellow is our input. We can change the signal also. This is the sine wave, and this is, we can see, this is our triangular wave, where we can see that only this portion, only this amount of portion is getting in the output, rest this portion is always 0, we can't get output here. In the similar way we can change the other wave also, and we can see that only this portion we are getting the output, only this amount of, where it is negative we are getting 0 voltage because it is giving reverse bias. So we can see similarly the square wave also, we are getting this positive one, in the negative one our voltage is 0, in case of negative the voltage is 0. In this way we can see that how the half wave rectifier is working. Now let us consider one important case here. If we want to take this all signal minus to plus in output, what we can do? It is very simple. We can see that this amplitude of this input is 5 volt, that is minus 5 to 5 volt. We can see here peak to peak voltage is 5 volt. I think peak to peak voltage is 5 volt. Let us count it by here. This is the one box is of 2 volt, so it is of 5 volt. So peak to peak voltage is 5 volt. It means there is 2.5 volt going negative. So if we apply 2.5 volt or more than 2.5 volt here in the input in positive side forward bias, then what we will get? By the principle of superposition we will get always be the this side will be at positive voltage. Let us understand it in some better way. Now I want to say that suppose here we have the input signal like this. This is the 0 volt, and if it is 5 volt or let us say 6 volt peak to peak, then it will be plus 3 volt and then it will be minus 3 volt. Now this 0 to minus 3 volt is being blocked by this diode due to reverse bias, and now I want all this minus 3 to plus 3 to cross. For this what we can do? We can add some positive voltage to this. How we will add that one? We will add here, make one battery, use of one battery at this place, we will use that battery. But what is the value of that battery, minimum value of that of voltage of that battery, so that the signal may cross? So that will be minimum of 3 volt to cross that. If we apply 3 volt, then what will happen? The origin will come here, that is 0 volt, and all the signals will appear above this line. So 3 volt will be reference here and the signal will appear like this. So there we can see now there is no case of reverse bias, because for reverse bias signal goes down the 0 volt, but now the signal is not going down the 0 volt, so we have no reverse bias, only we have here the forward bias, but here was the reverse bias and here was the forward bias. That is why only this was being seen at the output, this was being blocked, but here what is seen? All is seen at the output, there is no in the negative voltage. So to see this, let us add one battery here. So for that we will delete this wire. First of all we are going to delete this wire, we have to delete just one wire, and we will add one battery in the picture. So this is the battery, the voltage is 12 volt, let us decrease it, we do not need such high amount of voltage, we will keep just 6 volt, okay, and we will see the output now. So what we have to do? We have to now simulate it. So let us simulate it. The wave will appear in a minute. Now we can see here that we are getting the same, all this voltage appeared at the output, there is no cutting of the signal in the negative portion, because there is actually no negative portion, all is above the 0 volt. That is why we are getting the values like this. We can change any waveform and we can see we are getting all the signals. We can make it in the same as like this. Here we can see we can change any of it, and we are saying that the output is very much similar to the input, there is no cross or cut of input signal. In this way we can see that how the half wave rectifier circuit is working. So in the next video we will see about the full wave rectifier. That's all for this video.